Hi everyone, I'm Tanisha. I'm the relationship lead at Packt, and I have Namita with me. She's the growth lead at Packt. Welcome to this exciting session brought to you by Packt Publishing. Today, we are diving into the world of embedded systems, a field where performance, safety, and efficiency matter more than ever. And if you have ever felt stuck between legacy C code and the promise of modern C++, you are definitely in the right place.
That's right, Tanisha. Embedded development is evolving fast, and modern C++ has a lot to offer. Cleaner syntax, stronger type safety, and better abstraction. But let's face it, transitioning from C to modern C++ can feel overwhelming. That is why we are here to be thrilled about today's conversation.
Absolutely. Our guest for today is Amar Mahmutbegović, embedded engineer, educator, and author of the upcoming book C++ in Embedded Systems, a practical transition from C to modern C++. Amar has spent years helping embedded developers bridge the gap between the low-level control of C and the expressive power of modern C++. Amar, welcome. It's great to have you here.
Hi, Tanisha. It's so nice to be here, and I'm very much excited to be able to talk about my book.
Great. Thank you so much, Amar, for joining in today's session. So let's kick things off with your journey. That's the first question for the day. How did you first get into embedded systems, and what pulled you towards modern C++ in this space?
Yeah. So on my university, while studying the electrical engineering, I knew that what I want to do is embedded systems. So right after completing my degree, I co-founded company Assembly with my friend, and our mission is to develop embedded electronics systems. And as everyone, we started to use C for firmware development at first. But soon enough, I realized limitations of C, and a friend of mine introduced me to C++, and they were using it in his company for high performance computing in financial sector. So after discovering it, I realized that it can be very useful in the embedded systems, and then I started to slowly adopting it to our own projects.
Great to know your journey, Amar. And what inspired you to write this book, C++ in Embedded System? Was there a specific pain point or a pattern that you kept seeing in the field?
Yeah, so what I was constantly seeing is that embedded developers that are dominantly using C for their daily job still have some kind of misconceptions about C++. And that's one of the reasons I embarked on the journey of sharing my views of C++, first through LinkedIn posts and blog posts. And after that, I got on this journey of writing the book that is meant for C developers who would like to learn C++.
That's great. Thank you so much, Amar, for sharing your insights as well as your journey. Moving forward to the next question. A lot of developers are definitely hesitant about C++ in embedded work because of the perceived bloat or runtime costs. What are some of the misconceptions you wanted to address in this book?
Yeah, that's great one. So many C developers still believe that C++ is bloated and that introduce additional memory and runtime overhead. But that's not true. So C++ is guided by zero overhead principle, which means you don't pay for what you don't use. And if you use modern C++, that nowadays is even called contemporary C++, you can get a firmware code that's a great in performance, in size, and it's pretty much the same thing as you would write it. It's set by your own head, which means it's same in performance as you would write that code in, let's say, plain C. So that's one of the misconceptions that many still believe, and they even don't want to, learn more about what's possible and what's feasible with C++. And that's one of the goals of my book, to help people to discover C++ in the context of the embedded system development.
Got it. So, one of the core themes in your book is stepping away from macros and towards things like enum, class, and span. Can you just explain why that shift is so important?
Yeah, those are just a few things in C++ that are not present in C and which add to type safety and memory safety, which is, nowadays discussed more than ever. And for example, const expert allow you to define constant expressions, or let's call them just plainly constants, but with the benefit of adding a type to that constant so that your compiler knows which data type is being used and that prevents many mistakes and many bugs in your code. So const expert is just one of the things, and it can be used to define constants, but it can also be used to do compile time computation, something that's not possible in C. So you can write very complex mathematical functions, signals, do very complex calculations, and do all of that at compile time and store in your binary just result of those operations, which means you save both in binary, as that code will not be generated in machine code and added to your binary, but also in memory. You won't occupy so much of RAM. And also you will save a processing or CPU time, as no computations will be run at runtime and instead will be done for you by compiler at compile time, and only results of those operations would be saved in your binary. So that's just one of the things that's possible in C++, and it makes huge difference. You also mentioned span. So span is something that's also quite exciting for someone that's coming from C world. So it's a, let's call it simple wrapper that allows you to wrap a array's pointer and size, which prevents so many mistakes. So in C, it's quite custom to have those functions which accept pointer and length of an array, but std span does this for you. So it can wrap array in this context, plain C array, and also std array from standard library, C++ standard library, and many other containers. So it's something that adds to memory safety, as it's one of the most often issues with using row pointers and working with arrays is you can easily step behind the bounds of that array, and this is something that helps to address those kind of issues.
Great, great. Amazing. Thank you so much, Amar, for breaking down such complex processes into bite-sized information and, explaining it so well. Moving forward to the next question. A lot of developers in embedded systems deal with strict memory and timing constraints. How does your book help them adopt C++ without compromising on those requirements?
Yeah, so yet again, if you use Butter C++ properly, if you use things such as compile time computations, if you keep to the zero overhead principle, your code will be as efficient as C code, even better in terms of performance and memory footprint, as just recently we discussed the compile time computations. So really, that's something that you can't do in C and you can do in C++, and that means that no operations are done at runtime, and you have everything done at compile time and store results in your binary. Of course, this can be used only for pieces of code that rely on those premises. If you have inputs that comes in at runtime, you won't be able to use these features, of course, but still your code can be as efficient as a C code. And that's something that, many people still believe that C++ add overhead, but it does if you don't use it, I'll say, properly. But if you know what you're doing, then your code can be as efficient as C code. And my book guides you gradually through C++ and shows you how to use certain features of the language and how they can be applied to real problems from the embedded domain.
Amazing. That's great to hear. It seems very well aligned with what embedded developers face in the real world. And that is what the book is all about. Thank you so much, Amar. Moving on to the next question. So, we often hear from embedded developers in small teams or solo roles who worry about maintainability. How does the book speak to them?
Yeah, so maintainability is something that's quite important. And in my view, what adds to maintainability are two things. One is readability of code, and the other thing is flexibility of code. So when you're maintaining a project, you often need to address some issues, some bugs, and you often need to add some new features. And if your code is readable in terms of a human being able to easily read that code and go through that code naturally without additional cognitive burden, you can easily move through the code. So, for example, one of the things that C++ brings in are lambdas, and lambda allows you to wrap small functionalities and pass those lambdas to other functions that might call these functionalities. So you can think of it as passing in a callback. In C, what you need to do is to define a separate function and place it somewhere else in a file or in a separate file. So when you go through that code and when you get to the function that accepts callback, you need to scroll up or down in your file or move to another file to see actually what that functionality implements. But using lambdas just before passing that callback to a function, you can declare lambda and write what it does. So when you read the code, you can easily reason about what code is actually doing. So that's one of the things. That's readability, expressiveness of C++. The other one is flexibility, and flexibility is addressed through a design pattern. So, we have tons of problems that we are solving, but most of those problems have something in common, and we use design patterns to solve those common problems. And if you apply some of the design patterns that are suitable for embedded systems, then you can more easily adjust that code. You can expand it, add another feature, or made a fix. So those are the two components when it comes to the maintainability, readability, and flexibility, which are covered in my book. So if you want to have maintainable code, try to keep it readable and flexible. And you can read about those two things and how C++ brings to that in the book.
I think it's really well explained for the audiences. So, are there any tips that you'd like to give to C developers looking to, transition into C++ without diving headfirst? Any suggestions, any tips?
Yeah, so if you go through the book, you'll see that it slowly pulls you in C++ world. And if you want to apply some of these things, start small. So start using const expressions for defining constants, throw in a bit of lambdas, or, just take it one step at a time as you feel comfortable. And if this is your, personal side project, that's something that you are working on, just take it one step at a time. C++ is a big language. There are a lot of things and many features. Some of them are more complex than others, such as, let's say, templates and template metaprogramming. You don't necessarily need to use those in order to have some benefits of C++. Just having a C++ compiler and using const expert for starter, and even maybe stood span and things and those things that add to memory and type safety are great for starter. And you don't need to throw everything in once. So just, keep your own pace and do it one step at a time.
That's great. Thank you so much, Amar. Literally taking one step at a time, starting small is, the stepping stone into driving something really big. So that's a really great suggestion. Moving on to our final question for the day. As someone who's invested in both modern C++ and embedded systems, what excites you most about where this field is heading into the future?
Yeah, so what I'm actually seeing is that it seems like that people are starting to adopting C++ more and more. And in my opinion, that's due to the increased complexity of embedded projects. So embedded projects nowadays are much more complex than 10 years ago or so. So you have wireless connectivity, Wi-Fi, Bluetooth, other radios. You have a bunch of sensors. You're doing some processing. So the embedded systems are getting really complex, and that's something that C++ also helps with. So C++ in terms of language allows you to use higher levels of abstractions. Right. In C, you can do everything you can do in C++, but at much verbose level. So in C++, you can think more abstractly. It allows you that. The expressiveness of C++ allows you that. So I think that's one of the benefits and the reasons that C++ is being adopted more and more in embedded projects. The learning curve might be steeper. It definitely is than in C, but those benefits definitely pay off. And once you start using it, once you start adopting C++, things are much easier and you can implement more complex things easier than in, let's say, C.
Amazing. I think those were some really great answers, very well explained, Amar. This has been a truly insightful conversation. Your practical and grounded take on modern C++ and embedded system is going to help a lot of developers, I'm sure.
Absolutely. And for everyone watching, if you are trying to modernize your embedded projects or just want to write safer, more scalable code in C++, Amar's book, C++ in Embedded Systems, is a must have. You'll find actionable advice, field tested examples, and the kind of clarity that comes only from real world experiences.